Hi everyone, welcome to day 3 of polynomial unit. We are going to work through some more solving practice, but we need to make sure we learn all of the proper steps to get all possible cases. So last class and the class before, you really focused on graphing and factoring. We're going to start there and then see some other methods when those won't work. Okay, so pause the video and try this problem. It's a review from yesterday. So go ahead and give it a shot. I'm going to work it out really quickly. So you pause so that you can come back in solutions and we can get them by factoring easily. We can also look at them on the graph. And what I want you to see is that we have 4 total roots because of the 4th power, 2 rational roots at 1 and -1, and 2 irrational roots at -√3 and +√3. And so what those two are. Those are if you convert them to decimals, it's about -1.7 and +1.7, but we will not want you to write decimal answers down for these at this time. So we want you to find the exact answer, and if it has to be a radical, then it has to be a radical. So irrationals are usually radicals or things that can be written as fractions like pi, e, things like that, and then rational numbers are numbers that can be written as fractions, that's the main gist. So we're going to move along to another type of problem where we have something that we can factor. So we're going to go ahead and factor. Let's give it a try. And then when we try to keep going, what we're going to notice is that we have this second one is unfactorable. Nothing multiplies to -3 and then adds to +4. And so we do still have our 3 total roots, and we know one of them is at x equals 0 because I can see that from my factors, and that's our rational root. Crosses the graph at a whole number place or at a place that you can write as a fraction like 0 over anything. And so the other ones, we just don't know how to find out yet. And so those are our 2 irrational roots. So we're going to be answering the question, what do we do to solve for irrational roots? So let's see. What we can do is what we already started, where we factor out the x, and I'm just going to add a little note to that, or divide by x is another way I want you to think about it, because dividing is going to be important to us coming up. And so then we get x times x squared plus 4x minus 3 equals 0. And then, solving, we know that x equals 0, and then x squared plus 4x minus 3 equals 0. And so we can't factor it, but it is a quadratic, and so you can already see it on the screen. We'll use the quadratic formula. Yay. And so here's a little reminder of what that is. If you don't know it, go ahead and add it to your notes. If you do, then great. So x equals -b, so we have -4 plus or minus square root b squared minus 4ac all over 2a. And so I'm just going to work through this pretty quickly here. Feel free to pause at any time. 16 plus 12 is 28. I'm going to go ahead and write square root 28 all over 2. And then we want to reduce this radical, so we're going to do -4 plus or minus, find the biggest perfect square factor, so 2 or 4, square root of 4 is 2, and then we have 7 left over inside. And then we really would like you to reduce your final answer, so we'll divide everything by 2. So -2 plus or minus the square root of 7. And don't forget, those are our 2 irrational. Oops, I want to erase that. Our 2 irrational. Then we also had 0 as our 1 rational to make a total of 3 roots. So these are the answers right here. I'm just going to box those. All right, so it's not too bad. You just have to get it down to a quadratic, and then you can use the quadratic formula whenever it's not factorable from the beginning. And so here's another example of one. We have x to the third plus 5x squared minus 18x plus 8. Again, you can see that it has 3 total roots. I can tell that one of them is 2, right where it crosses the axis on 2. And that's going to be our rational root. And then the other 2, I can't tell what they are from the graph. I'm not comfortable putting those down. And so those are irrational. If you weren't sure on Desmos or even on your graphing calculator, you can find the zeros. And if you get a never-ending decimal that you don't recognize, then that would be like you don't recognize like 0.3 repeating is 1/3. If it's something else, then I would go ahead and assume it's irrational that you need to use this other method. So how do we do it? Let's remember what we just did. We divided out the factor that we did know, and then we turned it to a quadratic and used the quadratic formula. So we're going to do that exact same thing. Because we have one rational root at x equals 2, we know that x minus 2 equals 0, and we know that x minus 2 is a factor. And so that's from your first day and second day of notes so far. So that's just review. What we can do with that x minus 2 is divide it out. And if we divide x cubed by x, we'll be left with x squared, and we'll have a quadratic to use a quadratic formula. So right now, the only method we know is long division from like elementary, middle school. So we want to use that, but before I'm comfortable using that with you, I would like to do a quick review of long division with some basic numbers and not with the polynomials. So let's just do a quick refresher on long division. First, we want to see, what do I have? How many times does 6 go into 47? We look at the biggest number it will go into. That's going to be, I was going to put 8, but that's not true. 7. 6 times, and then we multiply the number on the outside by the number on the top. So that's 42. Then we subtract. 47 minus 42 is 5. Bring down the remaining numbers. And then repeat. How many times does 6 go into 52? This time it's 8. 6 times 8, multiply them. 48. Subtract, bring it down. Now 6 doesn't go into 4 at all. And I don't have any numbers left. And so for this class, we're going to stop here. I know that you could bring out a decimal. We're not doing decimals with polynomials. So we'll stop here, and we can write 4 6. Or 78 and 2/3 is our answer. Or sometimes we just write remainder of 4. That's fine too. You'll see it a bunch of different ways. So we're going to use that method with long division. Remember, at any point, if you need to pause and go back and look, feel free. So let's start with we have the number under, the term under the radicand. That's not right. That's not what it's called. But anyway, I have the thing that I'm dividing, what I'm dividing it by, and then we'll have our answer on the top. So let's start with what do we need to multiply x by to get x cubed? And so that's going to be x squared. So I put that on the top, and then I actually multiply everything on the outside by the number on the top, just like we did a few minutes ago. And so x times x squared is x cubed, and -2 times x squared is -2x squared. The next thing we'll do is subtract that whole thing from the polynomial. So I put it in parentheses. X cubed minus x cubed will always cancel. That's the point of doing that value. And then 5x squared minus -2x squared will become 7x squared. It's really plus. And then we just bring down the -18x plus 8, and then repeat the process until we get either a remainder of 0 or a number we can't multiply into anymore. So now what do I multiply x by to get 7x squared? That's 7x. And so a positive 7x, I'll put a plus. So let's do it. 7x times x, 7x squared. 7x times -2 is -14x. Then we subtract the whole thing. Cancels that out. -18x minus -14x is -4x. Bring down the 8. What do I multiply x by to get -4x? That would be -4. And so negative 4 times x, negative 4x, that's the goal. Negative 4 times negative 2, positive 8. And so then we'll subtract the last thing, and that cancels. And also 8 minus 8 will also cancel. And so we got a remainder of 0. And that's when we can stop, or we just got 0 and a remainder of 0. So if I had gotten something like 3 or 7, I could not multiply x by anything rational to get that, and so I would stop there. All right, so now we know that when we divide x cubed plus 5x squared minus 18x plus 8 by x minus 2, we get x squared plus 7x minus 4. So we're going to write that as a set of 2 factors so that it looks like what you were doing the other day. So we're going to finish solving now. Remember, x minus 2 equals 0 and x squared plus 7x minus 4 equals 0. We already know x equals 2, and now we need to use the quadratic formula to find the other one. So negative b plus or minus square root b squared minus 4ac all over 2a. All right, so we're going to do negative 7 plus or minus. This one's going to be 49 plus 16. So that would be 50 plus 16 is 66, so we'll do 65 all over 2. And then 65 is just the square, is just 13 times 5. And so that is not something that I can reduce. And so that's actually just my answer. And so I have 2 answers, or 3 answers. There's 2 here and 1 more there. And so I'm just going to box all those in for us. Oh, don't like that box. That's an ugly box. Okay. So that's not too bad. You just need to divide out the factor that we do know, get it to be a quadratic, and then you can use the quadratic formula. So that the long division isn't always the most fun. I'm just going to show that page again. I personally think it's really fun, but there is actually an easier way when we have a linear factor. So I'm just going to box linear factor and make sure we know that that is going to be like an ax plus b type of thing, anything like that. And so that's called synthetic division, and we're going to use that to get the quadratic a little bit faster. And I personally think synthetic division is really fun. It's like a little puzzle. So here are our steps. First thing we do is we set the factor equal to 0. So x minus 2 equals 0, and we know that x equals 2. Or we could just use the value that we get when we look at it in our calculator. Then we write the coefficients in descending order. And so that would be the coefficients of this polynomial right here. So 1, 5, negative 18, and 8. And then if there are any sort of value terms that get skipped, like if there was no x squared, I would put a 0 there for that. And then one thing I want to add is let's do and put it in the box, in this blue one. And so we're going to put this 2 out here in this box. This is how I do it. Other teachers might have done it a different way. And so then we bring the LC down. Oops. Let's see, 1. Try to keep my colors coordinated here. Okay, then what I do next is we bring the leading coefficient down. So I draw a little arrow and bring it down. And then we just multiply and then add all the way across. So 1 times 2 is 2. 5 plus 2 is 7. 7 times 2 is 14. Negative 18 plus 14 is negative 4. Negative 4 times 2 is negative 8. 8 minus 8 is 0. And we're going to box off this little remainder here. We should get a remainder of 0 every time when we do this. And now the numbers at the bottom are the new coefficients for a polynomial with 1 degree less than the original. So the original was x cubed. Now this is going to be 1x squared plus 7x minus 4. And so I'm just going to write it like this. And then we will repeat the process to use the quadratic formula. And so I have that on the next page. We'll practice this one more time if that was a little too fast. It's kind of spasming here. I think I want it to go back one more time. So just look at these steps one more time. You put the factor or the 0 in the box, write all the coefficients out, bring the leading coefficient down below the line, and then you just multiply by 0, add until you get to the last number. Okay, so we already know that we already did this, so I'm not going to do it again to save some time. We already know x equals 2, x equals -7 plus or minus square root 65 all over 2. So it's the same one as before. I just wanted to practice with synthetic. So we're going to do one example here. And so first thing we see is this polynomial. We'll just start. This is what you would do if you were starting from the beginning. So here's a polynomial. X cubed minus 2x squared equals 14x minus 3. Anytime you're solving, it should always be set equal to 0. And so I'm going to start there. X cubed minus 2x squared minus 14x plus 3 equals 0. And then your step 2 is to graph so that you can find any of the real rational zeros. And so I already just put the graph here, but you would just go into Desmos or your calculator. I can see it crosses at -3, and then this value I don't know, and this value I don't know, just from looking at this graph. And so I know that my real rational zero is x equals 3. And now we'll use synthetic division to reduce the polynomial to a quadratic. So I have it already as what it equals. I don't have to solve for x like I did on the previous example. I already know x equals 3, so I put that in the box. Then I write the coefficients, 1, -2, -14, and 3 across in descending order. I like to draw this line. And then you bring the leading coefficient down, and you multiply and add. Let's just fix this. Okay, there we go. -3. Then here we're going to get -5, +15, 1, -3, 0. Okay, then we have our quadratic x squared minus 5x plus 1 equals 0. And then we'll use the quadratic formula, -b plus or minus square root b squared minus 4ac all over 2a. And so we have x equals 5 plus or minus square root of 21 all over 2. That's 21 is not reducible, and so I'm going to add -3, and these are my 3 solutions. So hopefully this example shows you guys how to do it when you just from beginning to end. You graph. First of all, it needs to be equal to 0. Then you graph to find the zeros, use synthetic division to reduce it, and then you use the quadratic formula to find the remaining zeros. And we just have one more thing to cover. That's the remainder theorem. It's really quick. So this one is when you divide a polynomial by a linear expression, the remainder that you get from the division is the same as if you were to just plug that value in to the polynomial. And so here I have an example. We're going to use synthetic division to practice. So to use synthetic division, we set the divisor equal to 0 and solve. So then we're going to put 3 halves in the box, and then we put the coefficients in descending order, 1, 0, -2, and 1. And that will, let's see, that will get us. So bring down the 1, multiply it across by 3 halves, then bring down the 3 halves, then we get 9/4. -2 is like, it's just like having -8/4. So that's going to be 1/4. And then now when we multiply, we'll get 3/8. And then 1 plus 3/8 is 8/8 plus 3/8, which is 11/8. That's our remainder. I always box the remainder at the end. And so it's not 0. That means that 2x minus 3 is not a factor of that polynomial. And 11/8 is what we should also get when we plug that value in. And so we can check it. 3/2 cubed. Oh, there should be a 2 right here. So 3/2 cubed minus 2 times 3/2. And so you can check that in your calculator to verify that you get 11/8. If the remainder when dividing by, the second part of the remainder theorem says that if the remainder when dividing by x minus a is 0, then x minus a is a factor of p of x. And so we know that 2x minus 3 is not a factor of x cubed minus 2x plus 1. Alrighty. Here is our last 2 examples just to close it out. Why don't you pause it, give them a try, and then you can unpause and check the solutions or follow along as I go through them, but I would like for you to try it first. So first thing we do, set this equal to 0, x equals -1. Put -1 in the box, list the coefficients in descending order, and bring down the leading coefficient. Okay, that is the remainder. The remainder equals 3. Is x minus 4 a factor? So let's find out. We're going to put 4 in the box, list the coefficients, bring down the 2, multiply. When the remainder equals 0, then yes, x minus 4 is a factor. All right, well, that is our lesson for today. So we will practice that more tomorrow and look in Canvas to see if there's anything else for you to do. There may not be, but there may be. So just make sure you check there. And then we will pick back up tomorrow with practice this, and then we'll solve for complex zeros. Excuse me. Thank you guys for a great lesson, and I hope you have a great rest of your day.